Minor damage to plastic bumpers can be economically repaired with the FiberFlex universal welding rod from Polyvance. FiberFlex is a universal rod that sticks to nearly any plastic, but it is designed to work best on today's popular polypropylene and TPO bumpers. FiberFlex is formulated with carbon and glass fiber reinforcement for strength and sandable filler for sandability. FiberFlex works with Polyvance's airless plastic welding systems, like the 5700 HT Mini Weld Model 7 and the 5210 FiberFlex Repair Kit. This video will show you how to repair a simple tear to the edge of a plastic bumper using one of these airless welding tools and the FiberFlex welding rod. As you can see, this polypropylene bumper is torn to the edge. First, fixture the bumper so that the crack is lined up as closely as possible. On this bumper, there was some residual stress holding the crack open, so we put a bungee cord across the grill to take some stress off the bumper. Once the crack is lined up, use some of Polyvance's heavy aluminum tape to hold the crack together. Prior to grinding, we cleaned this bumper with Polyvance's 1001 EcoClean plastic cleaner. Next, grind the overspray off the backside of the bumper with coarse sandpaper. Don't spin the disc so fast as to melt and smear the plastic. You just want to put a good sand scratch into the plastic. You can also use a DA sander or sand by hand if necessary. Since this bumper is torn to the edge, to reinforce the repair, we'll cut a piece of the included 2045W stainless steel wire mesh to embed into the plastic. Cut it about the width of the flat welding tip and about the length of the crack. With the airless welder turned up to the maximum temperature setting, press down onto the wire mesh with the flat welder tip. Notice that we're using a sanding block here to support the bumper as we press down on it. Press firmly onto the mesh with the welder to transfer the heat through the mesh, melting the plastic underneath. Sink the mesh into the plastic like rebar in concrete to reinforce the repair. Continue to sink the mesh into the plastic until it is embedded all the way along its length. Once the melted plastic cools, sand by hand with a piece of 80 grit sandpaper to remove the gloss from the melted plastic. Since the FiberFlex is an adhesive that sticks to the surface, it sticks best to a roughed up sanded surface. Try to eliminate any glossy areas or sharp edges from the surface, then blow the area dust free. To apply the FiberFlex, pre-melt the end of the welding rod about 3/4 of an inch from the bottom. Quickly flip the melted welding rod over to put the sticky side down onto the plastic. Use the edge of the welder tip to cut that chunk off the welding rod. Then immediately use the hot welder tip to melt that chunk of FiberFlex and spread it onto the surface like peanut butter on a piece of toast. Move the tip slowly, letting the heat from the welder tip melt the FiberFlex before you spread it around. Note that we are not trying to melt the FiberFlex into the base plastic. FiberFlex is a hot melt adhesive that sticks to the surface of the plastic. That's why it's universal. It sticks to the surface and doesn't melt with the base. You can use the welder's heat to feather the edges into the plastic, but don't linger the heat and try to melt the FiberFlex with the base material. Continue to build a layer of FiberFlex over the backside to bury the mesh. The thicker you go with the FiberFlex, the stiffer and stronger the repair will be. Here we are putting 2 layers of FiberFlex over the mesh. After we let the weld on the backside cool thoroughly, we'll flip the bumper over and do the repair on the front side. As you can see, the repair is already pretty strong thanks to the stainless wire mesh. Grind a V-groove into the plastic with a die grinder to make room for the FiberFlex welding rod on the front side. Here we are using a round cutting burr to make more of a U-shaped groove, which works well for the FiberFlex. Remove the melted plastic slag from the edge with a putty knife. Next, use a small piece of coarse sandpaper to round off the sharp edges of the V-groove and make a smooth transition from the bumper's surface into the V-groove. Use the edge of the sandpaper disc to get down into the groove to scratch it up, as the FiberFlex will not stick well to the smooth surface created by the die grinder. It is always better to have a coarse sand scratch on the surface when applying the FiberFlex. Since it's so important that no shiny spots or sharp edges remain, we'll sand inside the V-groove by hand with 80 grit. Finally, feather the paint back and make a smooth transition into the V-groove using 80 grit sandpaper in a DA sander. We'll do a final touch-up sanding by hand to ensure that no more shiny spots remain and that everything has a dull, heavy sand scratch on it. Blow the area dust-free before applying FiberFlex. Melt and apply the FiberFlex into the V-groove just as you did on the backside. Again, Pre-melt the end of the welding rod about 3/4 of an inch from the bottom. Quickly flip the melted welding rod over to put the sticky side down onto the plastic. Use the edge of the welder tip to cut off that chunk of welding rod. Then immediately use the hot welder tip to melt that chunk of FiberFlex and spread it into the V-groove. Repeat this process until you fill the entire V-groove with FiberFlex welding rod. Here, we're adding another layer on top to make sure that all the low spots are filled proud of the surface. Once the FiberFlex is completely cool, sand it with a new piece of 80 grit paper in a DA sander. Try to keep the sander moving around so as not to concentrate the friction heat. The friction heat from the sander may soften the FiberFlex. If that's the case, let it cool and sand more later. It does help to use a new, sharp piece of sandpaper to cut the FiberFlex quickly. As you can see, we're putting quite a bit of stress on the repair to prove its strength. We can even beat the area with a hammer, and the FiberFlex repair and mesh will hold up to the abuse. FiberFlex can create a very strong repair you can be confident will last the life of the vehicle. In order to prepare the FiberFlex for paint, we first sand the area and feather the paint back with 180 grit sandpaper, then blow the area dust-free. We'll then spray a medium wet coat of 1050 Plastic Magic adhesion promoter to help our primer stick to the polypropylene. Polyvance recommends that Plastic Magic be used prior to any coating being applied to raw polypropylene or TPO substrates. Allow the Plastic Magic's solvents about 10 minutes to evaporate before applying any coating on top of it. Next, we are applying a medium wet coat of Polyvance's 3041 All Seasons Light Gray Waterborne Primer Surfacer. This will provide a coating that our two-part filler will be able to stick easily to. Allow the primer to dry completely. This can be accelerated by blowing some air over the surface. Here we are applying a glaze coat of Polyvance's 2000 Flex Filler Epoxy Adhesive Filler over the repair area. This epoxy two-part material is much more flexible than the popular polyester fillers and is recommended on flexible bumpers. Once the filler cures completely, use 80 grit paper in a DA sander to quickly knock the filler down to profile. Switch the sander over to 180 grit when you get close to the final profile to get the best feather edge on the material. Before applying the final coat of primer, again apply 1050 Plastic Magic over the raw polypropylene areas that have become exposed. After the solvents flash, apply another coat or two of the 3041 All Seasons Light Gray Primer Surfacer over the area. To finish, sand with 180 grit and 320 grit sandpaper. As you can see in this final shot, the surface is ready to be sealed and painted. Look to Polyvance for all the products you need to repair any type of automotive plastics. Polyvance has specialized in the field since 1981 and has the most extensive knowledge on plastic repair and refinishing in the industry.